Alright, so today we're going to present about air conditioning and refrigerant system component. Alright, so this is our group member, which is the first one is me, and second one is my friend. Alright, what is district cooling system? The DCS. The DCS is distributes cooling capacity in the form of chilled water or other medium form, a central source to multiple buildings through a network of underground pipes for use in space and process cooling. And why should we choose the DCS and why? It is individual user process chill water for their building from the district cooling system operator and do not need to install their own chiller plant. For the system, a central chiller plant, a pump house, and a distribution pipeline network are required. And the DCS is an energy efficient air conditioning system as it consumes 35% and 20% less electricity as compared with traditional air conditioning systems and individual water cooled air conditioning systems using cooling tower respective.
Next, there are a typical DCS comprises with the following components. First, central chiller plant. Generate chiller water for cooling purpose. Next, distribution network. Distribute chiller water to building. And the last one is consumer substation or user station. Interface with buildings own air conditioning circuits. Central chiller plant. Central chiller plant is the main facility in a district cooling system that produces chill water for cooling purpose. The chill water is generated at one central location and then supplied to multiple buildings through a distribution network. This system is more efficient because large capacity chillers can serve a number of buildings at the same time. It also helps reduce the need for each building to install its own separate chiller unit. In addition, the central chiller plant can use water-cooled chiller, cooling tower, pump, and other equipment to remove heat effectively. So, central chiller plant split to two systems, which the first system is absorption system and the second one is electric chiller system. So for absorption system is one type of chiller used in the central chiller plant. It works by using heat energy instead of relying mainly on electrical energy. In this system, the refrigerant absorbs heat and evaporates. Then the vapor is absorbed by another substance before being spread again using heat. Absorption chillers are suitable when waste heat, steam or hot water is available. They are quieter and produce less vibration, but their coefficient of performance or COP is usually lower than electrical chillers. They also require larger space and heavy equipment. Alright, for electric chiller system, an electric chiller system is a cooling system that uses electrical power to drive the compressor. It is widely used in district cooling plants because it has higher efficiency and higher COP compared to absorption chiller. The system cools water through the vapor compression cycle, and the chill water is then distributed to buildings. Electric chillers are easier to control, more compact in size, and commonly used for larger scale cooling applications. However, they depend heavily on electricity supply and may contribute to higher power consumption if not properly managed. For distribution network, The distribution network is the system that connects the central chiller plant to the buildings served by the district cooling system. Its main function is to deliver chill water from the plant to the user building and return the warmer water back to the plant for recooling. Normally, this network consists of underground insulated pipelines, including a supply pipe and return pipe. The supply pipe carries chiller water to the building, while the return pipe brings back water that has absorbed heat from the building cooling system. Pumps are used to maintain the water flow and pressure through the network. A good distribution network ensures reliable cooling, reduces energy losses, and allow one central plant to serve many buildings efficiently. So next for user station. The user station is the part of the district cooling system or DCS located at the building site. Its main function is to receive chiller water from the distribution network and transfer the cooling energy to building's internal air conditioning system. At the user station, equipment such as the heat exchangers, control valve, meters, and pump may be used to regulate and monitor the cooling supply. The, the chill water does not mix directly with the building water system because the heat exchangers separate both circuits. This helps improve safety, system control, and maintenance. The user station is important because it ensures that each building receives the required cooling capacity efficiently and reliably.
Alright, so this is our benefit for district cooling system. There are seven benefits. For this one, we have three, which is energy saving, reduce greenhouse gas emission, reduce noise pollution. Why energy saving? It is because the cooling system save energy because one central plant can provide cooling to many buildings more efficiently than separate systems. For reduce greenhouse gas emissions, district cooling systems helps reduce greenhouse gas emissions because lower energy consumption can reduce the use of fossil. And third is reduce noise pollution, which is district cooling system can reduces noise pollution because chillers and other major equipment are placed at the central plant instead of inside individual buildings. Number four is reduce refrigerant usage, which is district cooling system use less refrigerant because one central plant can serve many buildings without requiring each building to have its own chiller. Fifth is improve city skyline. The cooling system improve the city skyline because rooftops do not need bulky chiller equipment and can be used for other purposes. Six, improve building space utilizations. District cooling system improve building space utilizations because plan when there is no need for one-site chillers. And for cost saving, district cooling system can reduce overall operating and maintenance costs because building owners do not need to manage their own chiller plant. And this is the advantage and disadvantage for conventional system. For conventional system, there's two advantage and four disadvantage, which is for advantage is low cost for installation. Two is not disturb other plants if have a problem at chiller unit. And for the disadvantage, air conditioning use a lot of electricity and it a lot of number of manpower. It also cause higher maintenance for conventional system and need a large space. And this is for advantage and disadvantage district cooling system, which is have five advantage and two disadvantage, such as advantage improve efficiency of energy, protect environment, save space, improve urban view, and reduce manpower for operation and maintenance. For disadvantage is a higher capital cost of installation compared to installing chillers on the roof of each building. It also may be illegal issues of rigid agreement to install a recycling system if the benefits are to be shared between different legal entities. Next is the comparison between uh, DCS and conventional centralized water cooled and cooling system. As you can see, the equal for the electricity consumption is higher than two of the system, which is DCS and water cooled. So here you can see that equal is higher than water cooled, which is the electricity consumption is uh, 35%, and for water cooled compared to DCS is 20%. That means DCS electricity consumption is more lower than the water cooled, and air cooled is more higher. It means need higher electric consumption for air cooled. Thank you. That is for us.